I'm giving you a final problem in lesson 9.1 coordinate plane so that we have a chance to apply some skills together, kind of use them cooperatively, if you will. So our learning target might be to plot points, yes. It might also be to apply reflections to find new points. And it also really has a lot to do with, if you look here, we're going to create some line segments to create a polygon, or in this case a square. And when we're finally done, we're going to talk about some possibilities of some missing vertices or missing line segment. It looks like in a minute we're going to be missing points C and D. So we're combining a lot of skills here. Now, the learning target is really quite huge. So if I were to summarize, I would say we are trying to combine our coordinate plane skills of identifying points with the coordinate plane, and also our knowledge of polygons to be able to find some unknown vertices and complete an unknown shape. If we take a look here on number 15, part A, it says we want to plot point A at -3, 2 on the coordinate plane. So the first thing I want to do is practice plotting some points. So here I included a coordinate plane for us. If you start here at the origin, I want you to remember what happens if I move towards the right on the x-axis. Well, that's where I find my positive numbers. What happened if I move towards the left on my x-axis? Well, you're approaching those negative numbers. So the first number always tells me right or left on the x-axis. Next, we want to remember that the next number always has to do with the y-axis. The second coordinate always tells me either to go up towards the positives or down towards the negatives. So that'll be important as we move along. And again, it's always x before y, just like in the alphabet. A, B, C, D, x, and y. So the first point, starting here at the origin, tells me to move -3, meaning first move backwards, 1, 2, 3. And the second coordinate is a +2, telling me to move up, 1, 2. We'll put a point here and call this point A. Okay, we've done part A. All there was a point to plot. Well, part B gets a little more complex because we're going to apply some reflection skills. It says plot B, the reflection of A, about the x-axis. I want to find the reflection of A, and I want to make sure I'm using the x-axis as my mirror. So not only is the x-axis the first thing that we use when we're plotting points, it also is going to be my mirror. So I oftentimes will have students write that right next to this. I'll have them identify if the mirror is the x or the y-axis. And in this case, we're talking about the x-axis. Look across this mirror. I may even have them highlight the x-axis, so it might be a good idea right now if you highlight this x-axis, telling yourself, hey, the mirror's here. Look here to find the mirror. So if I wanted to talk about reflecting A about or across this mirror, the x-axis, well, A is looking down at the x-axis, isn't he? So he's going to actually end up seeing his reflection on the other side. But how far away will it be? Well, if I take a look here, point A is actually 1, 2 units away from the x-axis. Draw a dotted line in here for you maybe. Which means that point B should be the same distance away but on the other side of the mirror. So I'm going to measure or count here 2 units. Oh, there he is. Point B would be located right about here on my coordinate plane. And I'll give him a good label. That should be more of a point than a blob, but that's what's happening right now with my pen. Alright, I did what they asked. I made this reflection. It went right across the x-axis. Part B, all set. But then, part C asked me to give the coordinates for this new point B. What are its coordinates? So how would I locate this? Kind of a hard spot to find that in here, but I'm going to try to put a coordinate pair back here. And actually, rethinking it, it probably should have a good label. I probably should tell you that this is point B that I'm looking for, and then its coordinate pair. So the first thing we do, moving from the origin, is move back. Well, I'm heading towards -1, -2, -3. 3 jumps back is -3. That's my first coordinate. And if I move down from -3, I need to move down 1, 2 jumps, or 2 steps down, also heading towards the negative numbers. So that has to be a -2. Part C, we're all set. Let's move on. Part D says join these points A and B with a line segment. So I want to join these points with a line segment. Oh, I almost did quite by accident. My lines to measure my reflection or distance from the mirror could really be turned into a line segment right now, couldn't they? So remember, line segments are just a chunk of a line. They have a definite start and ending point. There's line segment AB. Okay, if we take a look at part E, AB, and actually it probably should say line segment AB. I think I did that when I was typing here. I didn't know how to show that notation and I forgot to try to put a little line above it. So let's read this as line segment AB is a side of a square ABCD. Oh, I want a square. This is important. A square with this name, meaning A is connected to B is connected to C is connected to D. Well, then it goes on to say there are name two, this is important, I usually underline this, highlight it, I need two possible sets of coordinates that could be the coordinates of points C and D. Two possible sets. Well, if I were making a square here, I know something about squares, so you have to rely a little bit on your polygon knowledge. Hopefully you say to yourself, I know squares have the same side lengths, so however long this edge is must be true for all the other edges. So it's important that I know how long this is, actually, to start with, so I could count from A to B. 1, 2, 3, 4. Looks like it's 4 jumps, and I'm just thinking a little bit better of it. I think it might be a good idea not to lose this important wording of 2, but maybe to get ourselves a smaller pen for the jumps. So 1, 2, 3, 4. Looks like it's 4 jumps. Well, if that's true on the side, wouldn't that also be true on the base, and true on the height, and true on the opposite side? Yes, because all sides of a square are congruent. So if I were to kind of emulate this idea, or repeat this idea, I know that the top also has to be 1, 2, 3, 4 units long. I could have a point here. And this edge moving down, this vertical line or edge, has to be also 1, 2, 3, 4 units long. Another point or vertex or vertices should be here. Next up, I want to connect point B to that new point. Let's see if I have a square. And I would caution you just to make sure, if you look, I think this coordinate plane got a little bit stretched out and skewed, but if we double check any edge, any of the edges on this polygon, they should be the same length. So are they? Let's go from B to this unknown point over here. Well, 1, 2, 3, 4. It is 4 units long. It looks a little bit stretched out to me visually, so just be careful and make sure that it's still true. It is. It just looks like our coordinate plane got a little bit stretched. Is it also 4 tall? 1, 2, 3, 4. Definitely is, which means the opposite side better be 1, 2, 3, 4 units in length. This actually is the square they're looking for. This is one possibility, but remember we're looking for 2. And before I move on, let's make sure we've done something. We label these. So I'm looking for square A, B, C, D. Well, the A and the B were set, but the C and the D were not. If I go in order, A connects to B, should connect to, oh, this should be point C. And C should connect to point D. Well then, how come D and A are connected? Look back and remember that the last point will enclose with the first point. They're going to connect. So D goes back to the very beginning to make my polygon. Well, this is one possibility, and it says I want to name 2 possible sets of coordinates that could represent points C and D. I just found one possible set. Here they are. This set here that I have in purple would be one possibility. So how about this? We could say set 1. C will have some coordinates, and D will have some coordinates. And let's think about how to find those. Well, starting here at the origin, to get to point C, I have to move 1 forward. That's a positive 1. I have to move 2 down. Moving down makes that negative. So positive 1, negative 2 will work. How about getting to D? Well, if you notice, it's almost a reflection about the x-axis. I still move positive 1 to the right, but instead of moving down to point C, I move up to point D. 1, 2. That's heading in a positive direction. Whenever your day looks up, that's a positive thing. This is one possibility. I like this as an answer, but let's remember, there should be 2. So instead of moving 4 units to the right of line segment AB, could I have gone a different direction? Well, can't really build up because that would change the length of my square, but I could definitely go the opposite way. Instead of moving to the right, could I move to the left? Let's give it a try. So, not sure what color we haven't touched here, but I'll try green. And remember, we want 4 units heading the opposite direction. Squares have the same side lengths. 1, 2, 3, 4. This looks like a possible vertice. Next up, I could do the same right here on the bottom. I could move from B and move across 1, 2, 3, 4. If I do that, I could find another vertex in here. So if I were to connect what I have going, let's see, if I connected A to B, I'll just run this green along the red, and B to C, oh, this must be point C, and C would have to go to the open point, D, and D would return and connect or enclose my polygon, point A. Does this indeed make a square? It might look a little bit stretched out to you, kind of like our last one did, but just double check. Is the height the same as the sides? 1, 2, 3, 4 for our height, and 1, 2, 3, 4 on this side. It looks to me like it is indeed a square. So we found our second set. Set 2. Well, point C and point D were in different locations this time, weren't they? Let's see. How would we get to point C? If I started here at the origin, we have to move backwards this time, quite a ways. I'm moving backwards -1, -2, -3, -4, -5, -6, -7 to get back here. And then I have to drop down twice. Well, I know -7 means I'm moving backwards, and dropping down means I need another negative. I drop down twice, that should be -2. Well, I want to take another look and figure out how to get to point D, so I start again at my origin, and I have to move again all the way back here to the same vertical line. That's still -7 back, isn't it? But this time, instead of moving down 2, I move up 2. It looks like I still move -7, but the difference is I'm not moving down, I'm moving up. That becomes a positive coordinate. This is a final answer. I have both sets included here. If you take a look, I hope you notice something. In set 1, these ones, they match, don't they? They're the same. So what changed here? The -2 to a +2. Oh, those are opposites. The opposites show a reflection. So when the first term stays the same and I see the opposites happening with the second term, I know that I have a reflection about or across the x-axis. Okay, so same x, and then opposites, maybe we write opposite y's, show reflection. How about this one? Is that true also? Looks like the x stayed the same again. Still a -7, still a -7. And what happened with the y term, or the y value? Looks like it was negative and it became positive. Again, it shows the opposites of y are showing me a reflection. Oh yeah, even C and D are reflections about the x-axis. Even over here, that was true. Kind of a challenging problem. Again, not all students are ready for this level of mastery, but I would expect that we are all able to plot these points and show an initial reflection. And then even if you can't find me both pairs of those new or unfamiliar coordinates for C and D, maybe you can work on just making me that square and finding at least one set. That would be a great start to see all students moving in that direction. So again, combining a lot of skills in this target, but can you apply your knowledge of coordinate plane and polygons to the coordinate plane? If so, when you're able to tackle this problem, you've probably mastered that target.